certain shape. It's very reactive. Kalau it's exposed to moisture ataupun air, dia boleh meletup, depending on the amount of sodium and water interacting. Chlorine pula adalah sejenis gas. Okay, if it's too much, it could be poisonous. Okay, boleh jadi poisonous dalam bahasa Melayu, beracun if it's too much. In World War I, the Germans, Nazi Germans, used chlorine gas in dalam perang lah, so it it works to poison the soldiers yang that fights them. So it's gas, poisonous, apa lagi yang very obvious. Tapi when they form a bond, dia akan menghasilkan table salt, garam. It contains none of these properties. Okay, garam kat rumah kamu tu, dia ada serbuk putih, kita boleh makan dengan selamat. Okay, it's no longer a type of metal, it's not shiny, it's not malleable. But it's reactive lah, but not in the same way as sodium, dia tak akan meletup. If you put salt in water, tak akan meletup. Tapi kalau kamu ambil a piece of sodium metal, letakkan dalam secawan air, dia akan cause a small explosion. It is also not a gas, ia sejenis kristal, and it's not poisonous. So itu maksud dalam soalan tadi bila dia kata, when elements combine, when they form chemical bond, they does not retain, they change their characteristics, they change their properties, physical and chemical properties, semuanya berubah. Okay, that's what we observe lah so far, and it tends to be true. Okay, moving on, next question. Review pun dah setengah jam. Mixtures can contain what? From the options here, kamu ada 4 options. Pure substance, gases only, solids only, everything except pure substance. Bahan bercampur boleh mengandungi apa? So you can choose 4 options here. Time's up. So the right answer adalah pure substance. Okay, basically kalau kalau nak mudah, mixtures can contain anything. If you see this pecahan of my mind map ni, mixture is a mix of elements and compounds lah. Okay, contohnya the air that we breathe. The air that we breathe, it contains elements and also it contains compound, because dalam udara yang kita breathe in, all the times, the air is made up of nitrogen. Nitrogen is like 70% of it. And then a small percent adalah oxygen gas. This is, tak silap saya, just about 20%. 9% adalah, carbon dioxide is 9%, lebih kurang lah. Okay, if you Google, you get a more accurate answer. And the rest are noble gases. Noble gases macam neon, radon, argon and so on. Okay, just traces amount lah, less than 1%. So this is a mixture. Ni nitrogen adalah element, oxygen is an element, CO2 is a compound, noble gases adalah element. So in a mixture, it can contain element and juga compound. Sama lah macam air pipe tadi tu, it contains water which is compound, a molecule. It contains element, chlorine. It also contains a compound of diluted acid. Okay, so in a mixture, it can contain pure substances. Next one. A mixture is a blend of 2 or more components. Okay, so secara tak langsung tadi masa saya explain about mixture and compound, we have answered this question. Let's see if you tangkap ataupun tak. Bahan bercampur tu adalah a what kind of blend? Campuran jenis apa antara dua bahan? Yang mana saya explain about air dengan minyak tadi, apa nama, kalau kamu cedok pasir dengan air laut, kamu letak dalam bucket. Okay, time's up. Sorry. It is a physical blend. Kamu 30 people, 30 of you, maybe kamu terconfuse ataupun tertukar. Okay, kat sini dia kata a mixture is a blank blend of two or more components. Okay, dia adalah physical blend sebab dia tidak bercampur secara kimia. Macam saya lukis tadi, let me go back to the drawing board. Okay, water and oil. Okay, dia tak bercampur secara kimia. Kalau dia bercampur secara kimia, dia akan it will take a lot more energy to separate them. Tapi kalau kamu nak asingkan antara oil dengan minyak, oil dengan water, you just need to tuang. You need to decant the oil out of the water. Okay, carefully tuang, slowly, sampailah the layer of oil is finish, you tuang, and then you stop. That's the only way kamu separate oil dengan water. Okay, that's how easy it is because they do not form a chemical bond. Kalau kamu nak separate a chemical bond macam proses electrolysis ataupun simpler example, kamu nak know there's still water, cannot think of an example. That's the change of phase. Kalau contohlah, I cannot think of an everyday example. Kalau macam proses electrolysis. Electrolysis is a process where you can separate the hydrogen and the oxygen in water. So you need a certain amount of heat, a certain amount of electricity to power the battery untuk pecahkan the H2O and H and oxygen atom. So dia akan, instead of water, kita akan hasilkan oxygen gas dan juga hydrogen gas. Okay, so it needs a lot of energy. Itu perbezaan antara a compound yang dihasilkan dengan chemical bond dengan a mixture yang terhasil daripada physical bond. Dia tidak terikat secara, the atoms does not form a chemical bond dalam mixture. Okay, so saya rasa kamu terconfuse juga ni. Maybe. Okay, next one. Diamond is an example of what? Diamond, berlian adalah sejenis, kalau saya nak explain tu dah bagi jawapan lah. It's a type of mineral yang that has been under a lot of pressure for a long time. So it is a different version of the element. Okay, semua dah jawab. The answer adalah element. Okay, so diamond is a type of carbon. A carbon that has been compressed for a long period of time. So it changes dia punya appearance, dia punya structure, solid structure dia pun berbeza. It is more hardy, it is brittle, it is shiny. Okay, so that is an example of element. Diamond is an example of element because it is made up of only carbon atoms only. Okay, last question. After this, we take 5. Potting soil, tanah yang kita guna untuk bercucuk tanam pokok tu. What is it? An example of an element ke, a compound ke, heterogeneous mixture ke, ataupun a solution? Alright, so time's up. The right answer adalah a heterogeneous mixture. Again, a potting soil, you can imagine, kalau kita nak tanam, kita mesti nak tanam pokok, potting soil, the most basic thing that you need adalah tanah dan juga baja, and then you letak pokok. And then bila pokok tu berinteraksi dengan tanah dan baja, dia akan excrete other chemicals dalam tanah, and they can absorb certain things into itself. So it is a mixture, a heterogeneous mixture, bahan yang bercampur yang tidak sebati. Okay, heterogeneous maksudnya dia tidak sebati, macam air dengan minyak tadi. Kalau homogeneous, dia bercampur dengan sebati, macam air dengan gula, air dengan garam. Your blood is another example. Okay, it contains a lot of things dalam darah tu, tapi dia campuran tu sebati. You just see a red liquid bila darah tu mengalir. Okay, berbeza dengan heterogeneous solution, mixture solution, macam contoh air dengan minyak tadi, you see a clear two layer of separation between the oil and the water. That's the, kalau kamu nak membantu kamu ingat these definitions, perbezaan antara this kind of mixtures, ada dua saja, heterogeneous and homogeneous. Just remember this simple example, darah and then this oil and water. Okay, so that's why the answer for potting soil ni adalah heterogeneous mixture. So let's take 5. Saya nak share the lecture notes, and then kita get back to our lesson today. Kita akan sambung into measurements and scientific notation. Okay, I'm back. Let me share my screen set. Okay, so kita akan continue our lesson. Tapi last week saya dah bagi homework and I saw that ada banyak response.
Sir, unmute your mic.
Sorry?
Your mic.
Tak dengar lah, sorry. My mic. Oh, I didn't turn it on. Sorry, 1 minute. Hey, tak dengar ke? It's on already?
Baru dengar.
Okay. I think it's wrong. Okay, so before kita continue with the topic measurements, saya nak discuss dulu the quizzes homework yang saya bagi last week, iaitu physical and chemical changes. Okay, this one, physical and chemical changes. So dalam this topic, kita nak tengok how matters, macam mana bahan-bahan yang kita dah study dalam the previous topic, bila dia bertindak balas, what will happen to them. So when we observe the reaction, and we have classified these reactions into two things, into two classifications, yaitu physical changes and chemical changes. Okay, so sekarang kita nak tengok what is physical changes and what is chemical changes. So dalam this question, the first slide, dia tunjuk a chemical change occur. A chemical change that looks like this. The physical change, it looks like this. So later kita akan go into the specifics. What makes a chemical change and what makes a physical change. So the first question, a blank change causes the substance to change to a new substance with different properties. So the answer here adalah chemical. So this is the definition of chemical change. Bila sesuatu tu melalui perubahan kimia, dia akan menghasilkan bahan yang baru dengan sifat-sifat yang berbeza, sifat kimia berbeza, sifat fizikal pun berbeza. Contoh yang saya dah bagi tadi adalah macam garam. Okay, garam dibuat terdiri daripada elemen sodium, metal dan juga elemen klorin, jenis gas. Okay, tapi bila dia mix, when they form a chemical bond, dia jadi garam. Dia jadi sesuatu bahan yang kita boleh makan. It's no longer poisonous, it's no longer metal, it's tasty to eat. Another example dalam this first slide ni adalah bahan yang dibakar. Apa-apa saja bahan bila dibakar, dia dah change dia punya chemical structure dia. Dia bukan lagi, kalau kamu ambil sehelai kertas, kamu bakar dia. So it's no longer paper. It has changed dia punya chemical and physical structure. Dia dah form new things. Bila sesuatu bahan tu dia dibakar, dia akan menghasilkan gas juga. So kalau bahan tu terdiri daripada elemen karbon, and then bila dia bertindak balas dengan api dan juga oksigen, dia akan menghasilkan carbon dioxide gas. So gas carbon dioxide itu terhasil daripada bahan yang mengandungi karbon tu terbakar. So the example dalam this slide adalah probably kayu ataupun kertas. So the same goes, the example still applies walaupun untuk kayu. Kayu contains the element carbon. So bila kayu dibakar, the carbon in the wood will react with the oxygen in the air dan juga dengan api. Api is the catalyst. So the carbon in the wood akan form a bond with oxygen, producing carbon dioxide gas. So that is the definition of a chemical change. Sesuatu bahan yang bila dia bertindak balas dengan sesuatu bahan yang lain, dia akan menghasilkan bahan yang baru. It will change dia punya physical and chemical appearance. Next question. A blank change only changes the look of the substance but not the chemical makeup. So the answer here adalah physical. Okay, there are two types of changes only yang kita study. Physical and chemical, very broad, very general. So kalau chemical change tadi kita tengok it changes the appearance, it changes the chemical makeup, it forms new substances. Tapi kalau physical change, it changes only the look of the substance. Dalam the first slide, kat sini dia tunjuk a wood that is being chopped by an axe. So kalau kamu ambil sebongkah kayu, kamu belah dua, that is an example of a chemical change. Kamu hanya ubah dia punya rupa sahaja. The appearance is only changed, but it's still a block of wood, it's still wood. Okay, dia punya chemical structure, chemical composition does not change. Next one, this is an example of what you have a watermelon, you cut it into small pieces. So by definition tadi, this is a physical change. It's still watermelon, cuma in small pieces. Next one, this is an example yang saya bagi tadi, a book that is being burned. Buku yang dibakar, it's no longer the same thing. It's no longer book. Dia dah jadi abu, and some of it, some atoms of the book is made up to form other gases, carbon dioxide. So it forms new substances. That is the definition of chemical change. Next example, vinegar. Cuka dan hydrochloric acid dan juga carbon dioxide gas. So new substances are formed. So when you identify that new substances have been formed, bila sesuatu bahan baru sudah dihasilkan, that is a chemical change. Next example, next question here, dia tunjuk a pencil that is broken into two pieces. So this is a physical change. Yang kat sini is ripening banana sampailah to the extent that is rotting. Here, a rotting banana, is it physical or chemical change? The answer is chemical. In new substances, pisang tu sudah bila dia masak is a chemical change. Dia punya more sugar are formed inside the banana. Lagi dia masak, lagi manis rasa pisang tu. So more sugar are formed. And then bila dah terlalu manis sangat, some bacteria akan feed on the sugar and they akan form rot. Okay, so this rot is more substances. So lebih banyak lagi bahan dihasilkan. So that is an example of chemical change. Next one, ini apa ni? Butter, melting butter. So this is chemical change. The melted butter is still butter, only in liquid form. You think bila dia berubah fasa saja, itu adalah physical change. Macam you ambil a cube of ice, you leave it on the table sampailah dia cair. And then walaupun dia dah berubah rupa fizikal, but it's still water, it's still H2O. If you take that same melted ice cube, you boil it, dia akan jadi water vapor, dia akan jadi gas, tapi it's still H2O, tapi dalam bentuk gas, dalam bentuk vapor. So bila dia only changes its physical, its phase, then it's a physical change. Next one, water tambah Kool-Aid. Kool-Aid is a kind of powder, drink powder in the US. Kat sini tak ada. So the person yang make this quizzes is from the US. Water plus Kool-Aid powder, is it physical or chemical change? It is a physical change. Okay, because it only changes the appearance of the water. The Kool-Aid is still Kool-Aid but dissolved in water. Okay, dia bukan bertukar jadi bahan yang baru. It's still sugar and it's still Kool-Aid and water, but Kool-Aid is sugar. It's sugar in color. Next one, the rusting metal. So is this physical to chemical change? If you think like when it's no longer the physical ataupun the chemical appearance, is no longer the same, then kamu boleh tahu which is it. So kalau kamu tengok besi pada asalnya adalah kukuh, keras, bersinar, shiny, tapi bila dah berkarat, it's no longer shiny, it's no longer strong. Kamu boleh ketuk-ketuk dia dan dia akan hancur. So when something goes to that extent of changes, itu adalah a chemical change. Next one, question 12 ni, leaves changing colors in the fall, ini adalah chemical change. Okay, the chemical reactions within the leaves causes the color to change. It does not get the nutrients, does not get enough nutrients. The cells in the leaves cannot perform photosynthesis anymore. So that's why they change color. Okay, so that's why it's classified as a chemical change. Next one, mixing sugar and water, is it physical ke chemical change? So the same macam PHCH dengan water tadi, ini adalah physical change. Walaupun dia larut sebati, tapi gula yang larut dengan air itu masih lagi gula. Okay. Next one, choose all of the following. There are chemical changes. Ada air yang mendidih, ada mancis yang dibakar, ada telur yang dipecahkan, ada telur yang dimasak, dan juga ada ice cream, popsicle yang sedang cair. So which of these 5 adalah physical change? Okay, so yang ada highlight green kat sini adalah air yang mendidih. Okay, air yang mendidih dia berubah dia punya rupa fizikal saja. In the beginning it was liquid, tapi in the end bila dah mendidih dia jadi gas, vapor. Tapi it's still H2O. The chemical composition is still H2O. Next adalah telur yang dipecahkan. So only physical appearance saja yang berubah kat sini. Pada asalnya it is the yolk is enclosed within the shells, tapi bila dipecahkan, it's still a yolk and shell. Okay, dia tak ubah dia punya chemical composition.
Sir, tak dengar suara, sir. Sir?
Okay, dia dah jadi. Hello, testing. Sekarang boleh dengar?
Okay dah, saya boleh dengar.
Dah.
Okay. Apa Ustaz boleh dengar? Ustaz tak boleh dengar. Okay. Kat mana example yang kamu start tak dengar tadi? Mancis. So kalau mancis, it is a chemical change. So after it is burned, bila dah habis dibakar, dia tak boleh gunakan mancis tu lagi dah, because there's nothing more left. Dia dah jadi abu. Okay, kenapa dia jadi abu? Because some atoms within the mancis sudah bertindak balas dengan api tu, producing other substances. Okay, macam saya cakap tadi, example macam kayu ataupun kertas dibakar, the carbons within those substances bertindak balas dengan oxygen within the air, producing carbon dioxide gas. So therefore, the chemical structure of the match sudah diuraikan, dah pecah dah, the chemical bond of the carbon with all the other atoms in the match. The same goes untuk telur yang dimasak ni. Okay, so bila telur ni dimasak, the protein within the egg undergoes the process kita panggil sebagai denaturation. The atoms within the molecules of the protein diuraikan, dirungkaikan. So that's why it changes color. Daripada clear, telur putih tu daripada clear dia jadi putih. Because the protein in the telur putih tu sudah diuraikan, it changes the appearance. It's not the same substance anymore. So when it changes the punya appearance and also the punya chemical structure, it undergoes chemical change. Okay, next one. This is the last one, yes. Last one, question 15. Choose all the following that are chemical change. Kita ada telur yang dimasak, the same macam tadi. Ada roti yang berkulat, avocado yang dipotong, apa ni? Oh, condensation, droplets of water form dekat tingkap, dan kayu yang dibakar. So the answer adalah telur yang dimasak, kayu dibakar, bulat yang terbentuk di atas roti. Okay, so semua ni adalah bahan-bahan yang baru. Kesemua gambar ni, all the examples in these three pictures, kamu boleh nampak new substances are formed. Okay, dalam roti ni bulat, bahan baru terhasil. Dalam telur ni dia punya the structure of the protein dalam telur putih tu, telur kuning tu pun berubah. That's why dia punya color change. That's why dia punya asalnya ada liquid, dia jadi solid. Okay, and this fire dia terbakar, dia jadi abu. New substance are formed, abu dan juga gas yang terhasil daripada pembakaran. Kenapa avocado ni bukan a chemical change? Because it only undergoes physical change only. That's it. It's still avocado. It tastes the same before and after you cut it. Okay? But it looks different. That's it. Ini pun sama. Droplets of water yang terhasil dekat tingkap ni, kita panggil proses condensation. Proses kondensasi. Water vapor dalam udara, bila dia bersentuh dengan permukaan yang sejuk, dia akan turn back, dia akan form back droplets of water. So that's why bila kita if you turn on aircon for so long and then it interacts directly with the glass wall, glass tu akan form droplets of water. And glass tu akan form droplets of water akan terbentuk pada permukaan gelas. Okay, dia masih lagi the water vapor dalam bentuk gas dalam udara, bila bersentuh dengan permukaan yang sejuk, dia bertukar dia punya rupa fizikal. But it's still water. Okay, so the purpose of this homework, the purpose of this lesson adalah untuk make sure you know how to differentiate between chemical and physical change. Okay, so this is a very valuable skill. Kamu perlu tahu bezakan which thing undergoes which kind of changes. From there kita boleh assess lah what should we do. Okay, in analysis, it is a fundamental skill. Alright, so moving on to the next topic, saya nak guna lecture note. Saya baru share pada cohort 18 tadi. So cohort 42 also kamu ada dalam ITEL, so you can go onto ITEL and download. Okay, so dalam first chapter ni kita dah kenali bahan. Apakah itu bahan? So we've classified substance into pure substance and juga mixture. We know there are elements and there are compounds and heterogeneous and homogeneous mixture. So why that's the first part of performing any analysis. The second part of it adalah kita nak measure. Okay, we need to measure.
Sir, tak ada suara.
Saya tak dengar. Sekejap. If I take the mic out. Hello? Hello, testing. Sekarang okey tak?
Okay, sir.
Okay, saya tak. Okay, thank you. Please let me know again kalau ada audio problem. Okay, so this topic kita nak tahu how to perform measurements. So how to perform measurements, in order for you to perform measurements, there are a few things that you need to understand first. There are multiple units of measurements. Ada pelbagai unit yang kita guna untuk mengukur. This is because there are there are a lot of dimensions yang kita boleh ukur. Dalam example saya bagi tadi, kita boleh ukur panjang, tinggi, if you measure 3D dimensions, kamu ada volume, isi padu, you can timbang berat. Okay, dalam more advanced example saya bagi tadi, kamu boleh determine the content, concentration, the dose of certain substances. So that's why ada pelbagai jenis unit. So kat dalam this first slide, let me masukkan dalam this. Okay, so dalam this slide, this is the SI units that we use in performing measurements in chemistry, in any scientific measurements lah, chemistry ke, physics ke, in math. So kalau mass, when we are measuring mass, kalau kamu nak timbang berat, the unit that we use adalah kilogram. Length in meter, time in seconds, temperature in Kelvin. We don't use degree Celsius. There's a reason why, and later bila sampai pada topik saya akan elaborate. The amount of substance in chemistry, kita guna unit mole, MOLE. Okay, so these are the units that we use to measure these things, this quantity, mass, length, time, temperature, and amount of substance. So the metric system yang kita guna untuk quantify the amount. Jadi kalau amount tu terlalu besar, kita tak tulis lah macam kalau macam 10,000 juta. So you don't actually write the 10 and then the 1,000 and then the juta. So we use abbreviation in metric system. So the prefix that we use, kalau macam kalau macam a billion, kalau macam a billion, 1 dengan 09, the prefix that we use adalah giga. The gigabyte unit that you use for your memory of your computer ataupun your electric device, itu maksudnya 10 kuasa 9. Ya ke? So, if you okay, so apa maksud 10 kuasa 9 ni? Some students have asked me that before. Okay, so this yang 10 kuasa 9, 10 kuasa 6, 10 kuasa 3 ni, we call it scientific notation. Okay, so the reason why we use scientific notation is so that we don't have to write the large numbers. Okay, 10 kuasa 9 here in this case, macam giga here, giga, the abbreviation is G. The meaning of giga is 10 kuasa 9. So what does that mean? So kalau kamu, mana this whiteboard? Okay. So kalau kamu, you have a device, okay, kalau kamu ada device, you have katakanlah the memory is 1 gigabyte. 1 gigabyte. That means 1 darab 10 kuasa 9 megabyte. Sorry. My bad. 1 10 kuasa 9 byte. Or is it bit? I don't know myself. But it's not giga lah. Giga here means 10 kuasa 9. So, what does this mean pula? Adalah bermaksud 1 kosong 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 kosong, is this right? 1 kosong hingga 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the 1000 juta bit. Okay, that's the amount of bit your device have. Bila dia cakap dia ada 1 gigabyte. Okay, so 10 kuasa 9, this is what it means, 10 kuasa 9. It's an abbreviation, singkatan untuk a very large number. So that's why instead of saying 1000 juta bit, we say 1 gigabyte. Okay? Let me besarkan balik. So the same logic applies untuk mega, untuk kilo. Kilogram yang kita guna tu is the same explanation. So 1 kilogram, 1 kg. K is kilo, G is gram.
Sir, tak dengar. Tak dengar.
Kilos wise 1 kilogram. So it's not the mic. I don't know what's the problem. Hello, testing. Maybe sebab saya guna dua devices. Let me buka my this one. Okay, so let me turn off the Bluetooth. Okay, so boleh dengar? Can you hear me?
Boleh
Yes,
sir, boleh.
sir.
Okay, thank you. Alright. Kalau ada macam echo ke? Okay, ada echo. Okay, testing. Okay, kalau ada echo ataupun dengar tak clear, please let me know. Let me turn up the volume. Saya tak dengar. Alright. Okay, so kalau tak dengar ataupun ada echo, please let me know. When did I stop this now? Okay, so kilo, yes, I was explaining about kilo tadi. So kilo means 10 to the power of 3, 10 kuasa 3. Deci means 10 kuasa negatif 1. So these are scientific notation. So what is scientific notation? It's just a way for us to express a very, very large number, macam gigabyte tadi. In reality, the actual value adalah 1,000 juta. Okay, 1,000 and then juta. Is it a billion? Is it the same? Okay, so this is the actual number for 1 gigabyte. 1,000 juta, yes. So when it's too big, it will not be efficient for us to perform calculations, not do reporting, not share information with other other researchers. Okay, so to help us to be more efficient in sharing data, sharing information, we use scientific notation. Okay, which is this singkatan, abbreviation of unit of numbers. So macam saya cakap tadi, kita guna ni untuk ringkaskan nombor yang terlalu besar dan juga nombor yang terlalu kecil. Because in chemistry we are dealing with substances that are so small. Contohnya macam the amount of atoms in a tablet, dan tablet Panadol. How many atoms of the API, active ingredient, are in the tablet? Okay, there are millions and millions of atoms. So kalau kita nak deal with something that is very, very small, we also use scientific notation. So kalau kamu nampak these values macam ini, untuk deci 10 kuasa negatif 1, ataupun untuk centi 10 kuasa negatif 2, mili 10 kuasa negatif 3, ataupun kat sini macam nano 10 kuasa negatif 9. So that's what nano means. If you heard about nanotechnology, basically it means we are dealing with technology that is very, very small. So the nano term yang digunakan dalam nanotechnology itu is not describing the bukan dia cakap tentang specific size of the technology, cuma dia nak cerita the technology is so small. Okay, so kalau macam nano 10 kuasa negatif 9, what does that mean? I use a simple example lah, macam centi. Okay, centi kalau macam centimeter. Here kalau kita nak definition of 1 meter, what's the whiteboard? Centi dalam slide tadi means 10 kuasa negatif 2. Okay, so how we write that in scientific notation? Kita tulis 1 darab 10 kuasa negatif 2. So in reality the value here adalah kita ambil this titik perpuluhan in front. Imagine there's a titik perpuluhan in front of this one. In front, on the right side of the number 1 here. You take it back 1 and 2. Kalau nombor 2 ada 2 dekat sini, so you take it back 2 times. So the actual value of this number adalah 0.01. So kalau if we are talking about macam sentimeter. Centimeter, the unit that we use untuk ukur panjang to measure the length of something. So centimeter means 1 darab 10 kuasa negatif 2 of a meter. So 0.01 meter. Okay, so that's why kalau kita nak convert between meter to centimeter, we divide the meter by 100. Because 100 ni adalah 1 per 100. 1 per 100, kalau kamu change, kalau kamu darabkan dia, bahagikan dia, kamu akan dapat 0.01 dan 0.01. Okay? So, apa yang kamu nampak dalam slide ni kita panggil sebagai the scientific notation of the metric system. Ni later. Sekarang kita nak tengok what is significant figures. Okay, so the term that we use, significant figures ni adalah, it refers to the digits yang kita ukur, the digits that we measure. Oh, ada delay. Are you listening? Are you hearing this right? Saya tengok kat sini saya ni ada delay. Hello, testing. Okay. So to not serabutkan this topic, okay, significant figures ni adalah cara kita, it's a method that we use to truthfully report our data. Okay, for example, kalau lah kamu nak buat calculation, let me go to this whiteboard. Okay, katakanlah you imagine kamu dekat rumah, kamu nak buat cake, kamu nak timbang the flour that you need to use. So the flour that you need to use, katakanlah kena timbang sebanyak 200 gram. So, no. Give you a more specific. Katakanlah kamu buka buku resepi, dia kata dia suruh timbang 200.58 gram. Okay, this is in the recipe. Buku resepi suruh timbang 200.58 gram. I know it doesn't make sense, but just go with me, okay? Katakanlah dia suruh timbang 200.58 gram. But you at home, you don't have this scale yang boleh measure sampai 2 titik perpuluhan ni. You only have the scale yang boleh timbang just nombor bulat, just integers. Meaning you can count, you can measure sampai 200 saja. The next number you can see after 200 is 201. So kamu tak dapat measure this titik perpuluhan here. So kamu tak boleh nak timbang exactly 258 gram. So this is the problem bila kita buat measurements, bila kita buat calculations, and kita nak report, bila kita nak translate dalam kita punya kerja. Okay, so we use significant figures untuk bantu kita mengukur dengan, as I'm saying this, saya lost students. Let me give you another example. Okay, let me go back. scrape that cake example off. Okay. Katakanlah, imagine a new situation. You have to ukur density sesuatu bahan. Katakanlah bahan tu adalah sabun. Okay. Katakanlah you work in a lab. That company buat sabun and then sampai dekat kamu kena determine, you have to determine the density of the soap. Density. So your work as this analyst, you have to determine the density of this soap, this block of soap here. Okay, so to determine this density, you need to determine this density, any density, you need to determine the mass of the substance and juga the volume, because this is how we express density. The unit of density adalah apakah unit density? A gram over milliliter, gram per mil. Okay, ataupun cara lain kita tulis gram. It's going to be confusing. Cara lain kita tulis unitnya gram per mil. This is correct. This is also correct. Okay, kamu kena cari mass and juga the volume. Kemudian ambil mass tu, bahagikan dengan volume, and then you get the density. Okay, so this is your job as this analyst dekat this soap company here. So the problem here kat sini, katakanlah kamu ambil berat dia, so you put it on a weighing scale, you find out it weighs 10 grams. Okay, this is the mass of the soap. And then you use a method, you determine dia punya volume. Okay, the volume you find out, katakanlah nombor yang tak bulat. No. Katakanlah volume dia adalah 3. I'm making up this example by the way. 33 mil. Okay, so kamu measure lah volume ni menggunakan instrumen, alat yang ada dalam lab kamu. So you find out the volume is 33 mil. And then you find out, you determine the mass, 10 gram. So in order for you to determine the density, you need to divide mass and volume. Bagikan mass ni dengan volume. So you take, say, draw a line here, okay? So density, this is the symbol untuk density, rho, equals to mass divided by volume. What I'm doing here is I'm trying to explain to you what is significant figure and why do we need it. Okay, so this is an example that I'm using to explain what is significant figure and why do we need significant figure. So kita nak bagikan 10 gram dengan 33 mil. So kat sini kita akan dapat, let me guna calculator, 1 minute. If I take 10 divided by 33, saya akan dapat 0.303030. Okay, so you can see this number, 0.3030. So the density is 0.303030 and goes on and on. So this is the problem. This is why we need significant figures, because this value here is theoretical. Okay, kita tak dapat this from actual measurements. Kita dapat this from calculation. Kita timbang 10 gram, tak ada titik perpuluhan. Just 10, let's say. Kita dapat dia punya mass. Kita measure dia punya volume, katakanlah one way I could think of to measure the volume of this sabun, kita cairkan dia jadi liquid and then kita masukkan dalam measuring cylinder, then kita dapat volume. And then kita find out the volume, isi padu dia adalah 33 ml. So tak ada titik perpuluhan pun. Tapi bila kita nak cari density, we divide the gram and the mil, the mass and the volume, kita dapat sampai this value. 0.303030 endless. It goes until what, 12 digits here, titik perpuluhan. The problem here is this value kat belakang ni, titik perpuluhan ni is theoretical. Kita tak boleh nak actually measure this value dalam makmal. If we, dalam makmal kita guna yang untuk ukur sabun ni, there's no actual instrument, tak ada pembaris, tak ada measuring cylinder, there's no instrument that we can use for us to get this value 0.303 gram per mil. Itu batan. So this is the problem, this data, this number here could not be true. Boleh jadi tak betul. So that's the problem with what measurements. You measure the gram 10 and 33 mil. Tapi bila kamu nak cari if you want to determine a dimension using these two value yang kamu measure, you get this value here, which you cannot verify. Kamu tak boleh nak buat ukuran untuk confirm this value. You just got this from calculation, 10 bagi 33. So we need significant figures untuk control, untuk standardize, so that everybody yang perform this measurement, perform this calculation untuk cari density ni is the same. Saya yang buat density, katakanlah saya kilang sabun dekat Malaysia, saya guna cara ni. Another kilang sabun dekat Perancis guna cara ni juga. Another one dekat Russia guna cara ni juga. It is standardized. Maksudnya semua orang guna kaedah yang sama. That way kita boleh control risiko untuk error. Maksud kalau semua orang buat salah yang sama, if there is a problem, kita boleh troubleshoot from there. Kita boleh investigate. Okay, did you use the same method? Did you convert? Did you use significant figures untuk report your data or not? Okay, so kalau orang tak guna, maybe that's why, that's the problem. So the problem here is, this value here could not be right. It could be wrong. So kita guna significant figures. Significant figures is a method. Is a guideline yang digunakan untuk kita report data. Okay, so for example, kalau significant figures, kalau saya ikut the guide of significant figures, the value yang saya patut tulis kat sini, the value of this density ni, saya perlu refer to the data that we have. Okay, so the first rule, ada beberapa rule dalam significant figures. These are the rules of significant figures. Macam mana nak besarkan? So the first rule of significant figures, all non-zero digits are significant. Nombor yang bukan kosong semuanya significant. Maksudnya accept that value. Kita tak boleh nak gundarkan dia. Jadi kita tak boleh nak ignore dia. Number two, the second rule is zeros between non-zero digits are significant. Number three, all zeros to the left are not significant. And zeros to the right are significant if there is a decimal point. So kalau saya nak report this density value yang saya baru kira tadi, saya perlu refer to the data yang saya ada. So the data that I have adalah the mass and the volume lah. Okay, so kita pilih mass ni, kita determine how many significant figures dia ada, 10 ni. So according to this rule, all non-zero digits adalah significant. So that means satu ni significant. Kosong ni kita belum determine lagi. So kosong dekat sini, zeros between non-zero digits are significant. So kalau kosong tu kalau dia diapit oleh non-zero, mana dia? Kosong kalau dia diapit oleh non-zero digits, dia adalah significant. But this is not the case. Okay, so ini kosong yang terletak di belah kanan. So let's look at kosong di belah kanan. Zeros to the right adalah significant kalau ada decimal point. So that means this one is not significant. So mass has one significant figures. Oops. So this one, there are one significant figure, one sig fig. Volume pula, number 33 ni, all non-zero digits are significant. So kita tahu volume ada two significant figures. So why do we need to determine the amount of significant figures in our data ni? Because bila kita nak report our final value, the one that we measured, kita mesti refer to the most significant figures yang ada in our data. Because that means bila kita report with the amount of the amount of significant figures of the data that we have, kita report to the extent yang tidak melampau. For example, kalau kita tak boleh nak tulis 0.303030330 sampai infinity. Because terlalu banyak sangat titik perpuluhan, we cannot verify. We cannot measure sampai tahap tu. So kita measure sampai tahap the amount of significant figures yang kita boleh measure using the tools that we could have in our lab. So the amount of figures yang kita untuk report in our end value here adalah 2 sahaja. That's the most that we could do. Okay, we determine this from the amount of significant figures of our initial data, which is mass and volume. So two significant figures. So the final answer here should be 2 significant figures sahaja. So from 0.3030330 ni, kamu tengok how many are significant. Okay, so kalau 2 significant figures, kita start from the left. Okay, so this is 1. This is 1 and this is 2. So kita patut bundarkan kosong ni to the nearest significant figure, which is 0 dan 3 lah. So how do I know kosong ni adalah significant? I'll tengok balik this guideline. Zeros to the left, all zeros to the left are not significant, so my bad. Okay, kosong di belah kiri semuanya tidak significant. So this is not the first significant figures. Let me padam this. So this is not the first significant figures. So this is the first significant figure. 3 ni. Okay, because dia kata dalam the first rule, all non-zero digits are significant. And then kita tengok dekat sini, mana dia? Kosong ni pula, sebelah 3 ni. Kosong ni, dia kata zeros between non-zero digits are significant. So, let me go back to this board. Kosong ni diapit oleh non-zero digits. Kosong ni diapit oleh 3 and another 3. So, this is also significant. So, this is the 2 significant figures. Sampai sini saja kita report. So, kita kena bundarkan this value kepada 2 significant figures. So, kita stop dekat kosong ni lah. So, kita kena bundarkan, kita tengok 3 ni. So, kalau kita nak bundarkan and the value on the right is 3, so kita just go down lah. Tak payah naik satu value. So 0.30 gram per mil. This is the value yang kita report. So instead of 0.30330, kita report only up to 2 significant figures only. This is the first significant figures and this is the second significant figures. Okay? So how do you determine which figures are significant? We follow these 4 rules, 4 guide. So it could be confusing now, but with more practice, it should get clearer lah. Tapi the most yang kita guna adalah this first 2. All non-zero digits are significant and zeros between non-zero digits are significant. 3 dan 4 ni dah get into very specifics. Ini kalau dah kira masuk titik perpuluhan. Okay, so that is significant figures. Why do we use it? Because kita nak report the honest reporting. Kita nak promote honest standardized reporting so that everyone in the world uses the same method. So it is more efficient for us to share data. So dalam this exercise, dalam lecture note ni, this is an exercise you can do on your own. You determine the amount of significant figures. 6.29, how many of it are significant? Okay, so dalam the first rule of significant figures, saya kata all non-zero digits adalah significant. So kesemua sini adalah significant. All of these numbers are significant. So ada 3 significant figures. 0.00348 3, 4 dan 8 ni adalah significant because all non-zero digits. Hello, testing.
Dengar sir. Dengar.
Dengar?
Dengar.
Oh, okay. So kalau 0.00348, 3, 4 dan 8 ni adalah significant because the first rule kata all non-zero digits adalah significant. And then that leaves us with these 3 zeros here, 0.00 ni. So kamu tengok, saya rewind balik saya. So tengok zeros, all zeros to the left of the first non-zero digit are not significant. So all zeros to the left to the first non-zero digit. This is the first non-zero digit, 3 ni. So all the non-zero digit to the left adalah tidak significant. So ini tak significant, ini tidak significant, ini pun tidak significant. So we have 3 significant figures. Okay, so that is why we that is how we determine which figure is significant or not. Kenapa kita nak determine? Because we want to bila kita nak report data, we want to report the values that we can verify with instruments that we have. Okay, so I think that's it for today. Significant figures and measurement. Oops. Sorry, saya punya holder battery habis. Alright, so that's it for today. Untuk we have another class later this week. Saya nak bagi homework untuk kamu tengok the videos dalam ITEL. So in ITEL, tapi cohort 19 tak boleh, saya tak show lagi playlist cohort 18. Watch this video by Professor Dave. Nanti saya akan post dalam ITEL juga dalam WhatsApp group untuk cohort 18. If you watch that video first, kita akan discuss the topic in that video in our next class. Alright? So, thank you. Kalau belum sign in attendance, saya rasa class rep dah share kan? Yes. So,
That's it sir.
okay, so that's it for class today. Thank you. See you.
Thank you sir.
Thank you.
Thank you sir.
Bye.
Thank you, sir.
Thank you, sir.
Thank you sir.
Thank you, sir.